In this class, we will discuss some of the problems on basic properties of fluids. So, we have learnt in the earlier videos about the definitions and units of basic properties of fluids, and also in the second video I had explained about the Newton's law of viscosity, and one problem we have done on that also. Now, in this class, I will explain three problems. The first problem is like this. If 5.27 meter cube of an oil weighs 44 kilonewton, find its mass density, specific weight, specific gravity and specific volume. So these are the basic properties we have done. So mass density is rho, specific weight is gamma, specific gravity is S, specific volume is V. So these four things we have to find out. So he has given only volume and weight of that fluid. Now, volume he has given 5.27 meter cube and weight he has given 44 kilonewton. So they are in SI units. So first, from the definitions of the properties, we can arrive at the values. So specific weight is defined as the ratio of weight to volume. So that is gamma. 44 kilonewton divided by 5.27 meter cube, which comes out to be 8.34 kilonewton per meter cube. That is the value of specific weight of that particular oil. Second one is mass density, or it is also called as specific mass, which is denoted by rho. So by knowing specific weight, you can find out specific mass or mass density by dividing gamma by G. So gamma is 8.34 into 10 power 3 Newton. We have to convert to Newton. Divided by G is 9.81 meter per second square. So if you simplify that, you get 851 kg per meter cube is the SI unit of rho. So you can see here this oil is lighter than water, because water specific that is specific mass value for water is 1000 kg per meter cube rho of water. Whereas here we got less than 1000, that means this whatever oil he has given, it is lighter than water. If the value is more than 1000, it will be heavier than water. Next, specific gravity, we know that it is the definition, it is the ratio of specific weight of the liquid to the specific weight of standard liquid. The standard liquid is water here. So we have got here 8.34 kilonewton per meter cube for this oil, whatever is given, divided by specific weight of water 9.81 kilonewton per meter cube. If you take the ratio, it is 0.851. It doesn't have any unit. Next, specific volume V is the reciprocal of the specific weight, that is 1 by gamma, which is 1 by 8.34, which is 0.119 meter cube per kilonewton. So the unit also will be reciprocal of that unit of gamma. So this is how we can find out the basic properties just by knowing weight and volume of a particular fluid. Now the second problem, in a fluid, dynamic viscosity is 0.048 poise, kinematic viscosity is 0.035 Stoke. Find its specific weight and specific gravity. So in this case, he has given the value of dynamic viscosity mu in terms of poise. So 0.048 poise. But please keep it in mind, when you are using the formula, we should substitute the values in terms of SI units. The SI unit of mu is Newton second per meter square or Pascal second, and we know that 1 Newton second per meter square is 10 poise. Therefore, to convert from poise to Newton second per meter square, we have to divide it by 10. So it will be 0.0048 Newton second per meter square. That is the value of mu now. Next, nu, this is the kinematic viscosity. Kinematic viscosity is given in Stoke. So 1 Stoke is centimeter square per second. So that should be converted to meter square per second. That is the SI unit. So what you have to do here is 1 centimeter is 10 power minus 2 meter. Square of that. So square of that. That means 10 power minus 4 you will get. So this value will be in meter square per second. This value will be in Newton second per meter square. Both are SI units. Please remember that whatever unit they give, so you have to convert them into SI units. That is very, very important before substituting in the formula. Now, according to the definition of kinematic viscosity, it is the ratio of dynamic viscosity to mass density of the fluid. So, therefore, I want rho now. So, rho is equal to mu divided by nu. Mu you have to substitute this value, nu you have to substitute this value. If you simplify, you get 1371.43 kg per meter cube. That is the SI unit of rho. When these two are in SI units, mu and rho are in SI units, mu and nu are in SI units, rho also should be in SI units. It is kg per meter cube. Now he has asked a specific weight, that is gamma. We know that gamma is equal to rho into g. So whatever rho you have got here, multiply that by 9.81 g value, you will get the value in Newton per meter cube, because gamma is in Newton per meter cube, 13,453.7 Newton per meter cube. Now specific gravity is the ratio of specific weight of the fluid to specific weight of water, which is 13,453.7 divided by 9,810. Please note that here the value I have substituted in Newton per meter cube. This also should be in Newton per meter cube. Whereas the earlier problem, it was in kilonewton per meter cube. This was also in kilonewton per meter cube. So both numerator and denominator should, both the gamma values should be in same units. So 1.371, that is the specific weight of, specific gravity of that particular fluid, whatever it may be, but it is heavier than water, because the specific gravity value is greater than 1. So you can say that this is heavier than water, whereas this problem here it is lighter than water because it is less than 1. So any fluid which has got specific gravity value greater than 1, it is heavier than water, less than 1 is lighter than water. Mercury, for mercury specific gravity value is 13.6. So that means mercury is 13.6 times heavier than water. Now in the third problem, at a certain point in a fluid flow, shear stress is 0.216 Newton per meter square. He has given tau value, shear stress value he has given, and velocity gradient is 0.216 per second. dV by dy value he has given. If the weight density of the fluid, that is gamma value, is 9 kilonewton per meter cube, find the kinematic viscosity, that is nu value. See, he has given tau value, dV by dy, velocity gradient value, and specific weight value. Of course, it is in kilonewton per meter cube. Convert that into Newton per meter cube, 9,000 Newton per meter cube. So because when you are substituting the formula, convert that into Newton per meter cube. Now according to Newton's law of viscosity, just in the last class I have explained, tau is equal to mu into dV by dy. So SI units you have to substitute here. You know the value of tau is given, dV by dy is given. Therefore mu is unknown. Mu is equal to tau divided by dV by dy. Tau is 0.216 Newton per meter square. dV by dy is 0.216 per second. If you simplify this, you will get 1. So it gets cancelled, 1 Newton second per meter square, or it can be Pascal second also, because Newton per meter square is called as Pascal. So Pascal second. So that is the value of mu. So directly we cannot find out the kinematic viscosity. So first we will find out the dynamic viscosity, then divide that value by g. Then we have to divide that value by rho. Now once you get mu value, specific weight value he has given 9 kilonewton per meter cube. So that becomes 9,000 Newton divided by 9.81 meter per second square. So you will be getting in terms of kg per meter cube, 917.43 kg per meter cube is the mass density or the specific mass of the fluid. When the dynamic viscosity is divided by the specific mass, you are going to get the kinematic viscosity nu. But be careful about the units. So this should be in Pascal second. This should be in kg per meter cube. Then whatever you get, so 1 divided by, so this value is 1 divided by 917.43, you are getting 1.09 into 10 power minus 3 meter square per second. This also will be in SI units, because these two are in SI units. This will be in SI unit. SI unit of nu is meter square per second. Later on you can convert into Stokes. How to convert into Stokes? 1 meter is 10 square, 100 centimeters. Therefore 1 meter square will be 10 power 4 centimeter square. If you simplify, if you convert this into centimeter square per second, so you will be getting 10.9 strokes or centimeter square per second. So why I have taken this problem is you should be in a position to convert whatever may be the units they give, you should be in a position to convert them to SI units. Then you have to substitute in the respective formula. The answer also will be whatever known is there, that also will be there in SI units.